TIG welding, or tungsten inert gas welding, is a welding process that uses a non-consumable tungsten electrode to create the weld. This process is also known as gas tungsten arc welding, GTAW. TIG welding offers precise control over the welding arc, making it suitable for a variety of materials and applications. Here's an overview of the TIG welding process. TIG welding requires a TIG welding machine, which typically includes a power source, a foot pedal or hand control for amperage adjustment, and a TIG torch. The torch holds a non-consumable tungsten electrode, and a separate filler rod is used for adding material to the weld if needed. A shielding gas, usually argon or a mixture of argon and helium, is used to protect the weld area from atmospheric contamination. Tungsten electrodes come in various types, such as pure tungsten, thoriated tungsten, serrated tungsten, and lanthanated tungsten. The choice of tungsten depends on the material being welded and specific welding requirements. Argon is the most commonly used shielding gas for TIG welding. Helium or a mixture of argon and helium may be used for certain applications. The shielding gas prevents oxidation and contamination of the weld by creating a stable arc and shielding the molten weld pool. Proper joint preparation is essential for TIG welding. The surfaces to be welded should be clean, free of contaminants, and properly aligned. TIG welding is often used for welding thin materials in critical applications where precision is crucial. TIG welding allows for various methods of arc initiation, including scratch start, lift start, and high-frequency start. In scratch start, the tungsten electrode is touched to the workpiece and then lifted to create the arc. Lift start involves touching the electrode to the workpiece and lifting it slightly to initiate the arc. High-frequency start uses high-frequency electrical energy to initiate the arc without physical contact. The TIG welder controls the welding current using a foot pedal or hand control, adjusting the heat input based on the welding requirements. The tungsten electrode is held at a precise distance from the workpiece, and the welder uses the TIG torch to direct the arc along the joint. If additional material is needed, a filler rod is added manually to the molten weld pool. As the welding torch moves along the joint, the molten metal solidifies, creating a strong and precise weld. After welding, it's essential to clean the weld area to remove any residual contamination. Inspect the weld for defects and ensure it meets the required quality standards. TIG welding is commonly used for welding materials like stainless steel, aluminum, titanium, and exotic alloys, as well as in applications where precise control and high-quality welds are critical. It is widely employed in industries such as aerospace, automotive, and manufacturing. TIG welding is known for producing clean, high-quality welds with minimal spatter. There are two main types of polarities used in TIG welding: direct current electrode negative, DCEN, and direct current electrode positive, DCEP. DCEN, DC, will be further explained in Part 2. Electrodes will also be discussed. For more, subscribe to my channel.